Hello. So I'm Ethan, and in this video, I'm going to talk a little bit about Litterman computer. So first off, what is Litterman computer? Litterman computer is basically a simulation for beginners, which can help them understand basic computer concepts. I'm sharing this information because I personally found it to be quite useful in terms of learning and getting and understanding what each component of the CPU does and how it actually works in the background. So here, this is the simple program that I was trying to make. So if you look at the flowchart, if you know about programming already, you can see that it is basically a continuous adder. Basically, you have an input, you then store it inside a variable. After that, you loop back and you see whether if the input is greater than or equal to 0, if input is greater than 0, so which means that the user still wants to input, then we do the same loop again. But if the input is 0 or less than 0, which basically means that the user doesn't want to input anymore in this particular sense, we basically display the output, which is the continuous sum of all the numbers the user will input. And after displaying the sum, we'll basically ask the user whether if they want to continue the input or not. If they want to continue, everything will be resetted and go back to the start again. So that is the basic program. So in Python, if you were to do this in Python, it would be very simple. Basically, oh sorry, I got a bit confused. While true, oh my god. Num equal input please enter a number. So I'm just trying to demonstrate how the code would look like if you were to write it in Python. So sorry, sum plus equal num, and then if num, we'll first check if num is greater than 0, continue, else we'll break, print the sum, fine. Input, continue or not equal input, do you want to continue, in this case, because we are simulating CPU, we'll just do it in a number sense, integer sense. So if continue or not greater than 0, which means we still want to continue, we'll just break. So less than or equal to 0, we'll break. Print, program ends. So if we were to run this, you'll see until number 10 10, 0. The sum is 0. Do you want to continue? Yes. And then we start over everything again. 0. We get 40. So you don't want to continue anymore, you just quit. So in Python, this is how the program would look like. Sorry if I took some time to do this. But right now, let's look into Little Computer. I mean, although I'm familiar with coding a bit, I wasn't really familiar with assembly. I got a bit confused on how it works for like, I think 1 hour. But since I already have the basics in coding, I can understand it relatively fast. So here, in Little Computer, they use assembly code. In assembly, there are several commands. Like as you can see, you get all of these. Input, output, hard means basically the program's ending. Add, we basically adds the value. Subtract, and then store the particular value inside the accumulator into a specific storage address. And then LDA means that we load a specific value from a specific address into the accumulator. And after that, we have BIA, BRC, BRP, which to me seems like if conditions. Like if condition in the sense that you can use it to, write conditional statements. In this particular program, I make it so that it is a loop. And we have output. I haven't really used this OTC as a 22, so I'm not really using that. So let me just try to simulate it. So we assemble it into the run first. Actually, it's already assembled. So we first run. As you can see, the command goes to the first box and it retrieves the instruction and it asks for the input. As you can see here, IMP is the input command. So basically in Little Computer, it stores the instruction inside each address registers, and you can do something about them. And for each of these individual commands are stored inside, as you can see, 00 is inside 0 and the command is 901. And all the other commands are also stored inside here till 10, actually 11, because 000 is the hard command. Basically, it tells the computer to stop. So let's see how it works. First off, as you can see earlier, the CPU sends an instruction request fetch command to the 00 address, and it retrieves the 901. 901 is basically input. So it requests for input right now. Let's just say we input 10 inside there. And then it goes to the second command, which is BRC. BRC checks whether if the value inside the accumulator is 0 or not. If it's not 0, it doesn't do anything. It just continue on. So now it's at 399, stole. STA is basically stole. Like basically we are telling it to store the value in the accumulator inside storage 99. And then it goes to the next instruction, 198. Basically it is telling to add the value inside 98 into the accumulator. So we get the sum value. And then after getting the sum, we store it back inside the storage 98. Like the reason it was 0 is because there wasn't any value in the first place. So that's why it was 0. Now 0 plus 10 is equal to 10. And that's why we are here. So it's now doing all the other things. Now it has already looped back to the very start. Like the same thing here as the Python program. It goes back to check from this part. It goes back to check whether if the user still wants to input a number or not. let's just input another number, 20. Go inside there. Now it checks whether if the value is 0 or not. Since it is not 0, it will just continue. 399. It stores the value inside here in storage register 99. And it goes again to 198. So it will retrieve the value inside 98 and add it with the value inside the accumulator. It is going 10. As you can see, it goes plus. Hey, you got 30. And then it's those, and then we go 398. 398 is basically it is asking to store the value inside here. And then it goes to 600. Basically, if it checks whether if the value is 0. Actually, it is trying to loop. I'm sorry. As usual. And then again, the same thing happens. It will ask for the input again. Now, if we input 0, which means we don't want to input the number anymore, basically, it will basically do the output. So it goes inside here. It checks whether if the value is 0 or not. It is. So it literally skips the entire process and goes to the output phase. So it first retrieves the value from the variable and then store it inside the accumulator first. And after that, we go to the next instruction, 902. 902 is basically output instruction. So we are basically going to output the value inside the accumulator. Here, you can see the sum output. So 901, we are asking for the user input again. This is this phase. So we are basically asking if the user wants to continue or not. Since he doesn't want to continue, since we don't want to continue anymore, we'll just input 0. It will go there. It check the condition. Like if it is like 711 is basically this one. It checks whether if the value is 0 or not. If it's not 0, if it is 0, you will just basically skip to here, 0, 0, which means we want to exit. Since it is not, if it was not 0, it will go to register 10. Register 10 basically tells the program to skip back to the instruction register 0 and ask for the input. So which basically makes the entire program loop again. So this is me trying to understand how Litterman computer work, and that's all. If you want to learn a bit more about Litterman computer, I will suggest this particular video by Andy Dolinsky. I will try to link it down below. So that's all. Thank you so much.